from the land of Hans Christian Andersen. So I know it's late, I know you're tired, I know that you're dying to go home. Some of you probably have a train to catch. I'll try to make this as interesting and exciting as possible and hope that you stay until the end, even if it means that you'll miss your train. So, first a word from my sponsor. So, I'm sponsored by the Scandinavian Network of Excellence in Software Configuration Management, and for some strange reason, they also have an Italian branch. And they have a summit twice a year. They've been meeting for 4 years. The next time is in Pavia on April 20. It's a small informal group, 15 to 20 people. We have a lot of discussions. There are some presentations, but most of it is open spaces. It's free. There is something about continuous delivery, Devops and stuff like that, but it's always got a software configuration management focus. If you're interested, go to the website and there's more information. So, I'm Lars. I'm Danish. I got my master and my PhD from Aarhus University and Aalborg University. I started working in Aalborg, Denmark, and in 2001 I was headhunted by Lund University in Sweden. I've been interested in software configuration management for 30 plus years. I tried to convince my colleagues in Aalborg that I should actually teach some software configuration management to our students, but somehow I never managed to convince them. So when they promised me a dedicated course in Lund, it was an easy decision. So since 2001, I have run 1 out of 2 university courses on software configuration management in the whole academic world. So if you want to have an academic course on software configuration management, you either have to come to Lund or you have to go to Rio. I think you should go to Lund. In the last years when I was at Aalborg University, some students got me interested on this agile thing. So some students, they came to me and said, we read about something exciting, something new. It's called extreme programming. It means that we can do anything that we want. No more processes, no more discipline, no more. I said, I don't think so. They said, yeah. So I studied it, and a couple of weeks later I had to tell the students, sorry, you can't do what you want to. You need to be disciplined. When I arrived in Lund, they were remodeling one of their project courses to follow extreme programming, so we run extreme programming projects with our students, and I've been involved in that as a coach, as a customer, and for the past 5 years I have taken over on the coaching course. So I'm the one coaching the coaches for these agile student projects. And I also do some research and industry networking. And I'm Paolo. Well, actually, I'm not Paolo. Unfortunately, Paolo could not be here today. He's Italian. He got most of his education in Udine in Italy. Then he moved to Denmark and very quickly took another master's degree and very quickly a PhD. And he's been teaching and doing research at the IT University in Copenhagen since. He's interested in global distributed software engineering, software architecture, computer supported cooperative work, and we have managed to get him interested in continuous whatever things. So we are doing a research project on that. Who is Hans Christian Andersen? Well, he's a Danish author, the author of many famous fairy tales, The Nightingale, The Little Mermaid, The Snow Queen, The Ugly Duckling, Thumbelina, The Emperor's New Clothes, The Princess and the Pea, and my favorite, A Poet's Bazaar, which is a 2-volume travel diary where he's describing all his experience traveling around Europe. And there are some things, interesting things, also from Italy. And it's illustrated with his own drawings. Outside of Denmark, and probably also inside Denmark, he's famous for his fairy tales. But he was also fairly able at doing paper cuttings. These are paper cuttings that he made with scissors, and he was making children happy wherever he went, because he did those for the children and gave them to the children. So we are not going to talk about paper cuttings today. So those of you, if there are any of you who have heard me before, will have seen this one. This is how my students, they look at continuous delivery, continuous deployment. So we got some stories and features. They have to end up being released or put into production. And how that is done? Well, we got the code fairy sprinkling some magic dust, and poof, it goes into operation. There's a little bit more in that. So the code fairy tale is one of the few fairy tales that Hans Christian Andersen didn't write, and we're not going to talk about that today. So I hope that what we'll get through today will not be the Emperor's new clothes. It should be the ugly duckling turning into a beautiful swan. Now, I've been here twice before. In 2016, I was reporting about some experiences from our students being exposed to continuous delivery, inexperienced rather naive students. The learnings from that was that continuous delivery is like a fail-fast development method. The magic dust number one is that it's all about feedback, and we need to get feedback as fast as possible. We had to avoid bottlenecks, so we should plan for scalability. So if it works in the small, it should also work when we get more stories and more velocity. Magic dust number two, avoid idle time. So we don't have to sit and wait. We should automate, automate, and automate to speed up things. When in trouble, roll forward. I've seen a couple of presentations today where people have been talking about, well, if something happens, we can roll back. I've been teaching that to my students for years, because that's what we do in software configuration management. We can roll back things for you if you fuck up. We can sort of undo it. But I've learned that when we do continuous delivery, when we do this kind of fail-fast development, then we don't roll back. We roll forward. And we can do that fast. So in reality, fail-fast development looks a little bit like test-driven development. So we have some specifications for the system that it should satisfy, and we automatically test whether they are satisfied. If they're satisfied, it goes into production. It's done. Test-driven development, we write some unit test. When we get green all over, the feature is done and it goes into production. And something that I have to tell to my students, I probably don't have to tell it to you, is that you should never ever compromise on quality. Quality assurance and test are your friends, not your enemies. So they're trying to help you. Last year, I reported from research literature and experience reports from industry what their experience is with continuous delivery, what is it that we know for a fact, and what are just stories that we hear about. So fact number one is, well, no surprise, it's all about feedback. Fast feedback, that's why we do continuous delivery. We want to have feedback continuously and very fast. Fact number two, the delivery frequency that we found from literature and from real life ranges from Facebook, that does a couple of deliveries every second during peak time, to like Firefox, which, because it's easy to research on, a lot of research has been done on Firefox and development of Firefox, they have releases from time to time. More frequent now than they had some years ago. Customers, the customer experience quality did not suffer. So because we get into continuous delivery, continuous deployment, it doesn't mean that quality goes down. Developer productivity does not go down. So even though they have to do a lot of more things, they have to do also the testing, which they're not maybe so used to. They actually have more, in many cases, have more productivity. And we found that in some cases you need to balance the speed and the quality of your continuous delivery pipelines. So sometimes you want to have very, very fast feedback, and other times you want to have very, very high quality. And you'll probably have two different pipelines for that. And never ever trust that hair can grow on a bald man's head, no matter what consultants they promise you. Now I'm back again with some fairy tales. So what will you learn today? Well, we're starting up a research project in Denmark on continuous software engineering. And as part of starting up that, we did some interviews with a good handful of Danish companies, different sizes, different sectors, and at different points of their continuous delivery voyage towards paradise or whatever the edge they want to go to. What we wanted to find out was what were the pitfalls, what were the problems that these people have experienced. So how can we avoid them or get around them? What bumps have there been on the road? And what is it that we should look out for? And paradise. Actually, one of the companies claimed that they were among the best continuous deployment companies in the world. They actually had been at a conference in the US and came back very disappointed because there was nothing that they could learn from that conference. So how did they get there? What was it that they did? Probably you cannot do the same thing, but maybe you can be inspired. So in a certain sense, what are the prerequisites that we need to satisfy in able to be successful when we go against this continuous delivery thing? First, I'm a university professor, so we need a little terminology. So what is continuous delivery? Well, in this context, continuous delivery will be discovering release candidates. So when you have made some changes, implemented a feature, a bug fix or whatever, you say, I have a potential release candidate now. We need to check that and verify that. And that's what we do in continuous delivery. If it passes, then it's a potential release candidate. If not, he'll get it back and he'll have to fix it. What is continuous deployment? Continuous deployment means that every little change that we want to do, if it passes all the things that it should pass, then it goes directly into production. What we discovered was that most of the companies, except from the Paradise company, they didn't want to do continuous deployment. They were sort of scared. It didn't feel good in their stomach to know that when I commit something, it might end up in production. That feels scary. So they wanted a button such that when it went to be a release candidate, then by human intervention, you could push that button and then automatically it would be deployed into production. And if you had gone home for the weekend, then you would push the button on Monday morning or whatever. So they didn't want to go all the way, but the Paradise company did. What is DevOps for our purpose? It means that Dev and Ops is done by the same team. And I found out during the preparation for this presentation that I also needed a definition for continuous. So I looked up in the dictionary, and one of the definitions is that something is done without interruption. So continuous deployment means that once you think that you're done, then without interruption, it goes into production. Now, you can look at this in many different ways. Consultants, they usually draw a triangle with people, processes, and tools, and I thought that might be a good framework. Let's start with the tools. As the keynote this morning noticed, then continuous delivery and DevOps is not really about tools. I have a slide about tools. I have, I think, 1.5 slides about tools. Most of it is probably processes anyway. It's much more about culture and people. When we interviewed the companies, people said, well, the tooling part is not easy. It can be cumbersome, but it's not really a problem. It's not a challenge. It's not something that we're struggling with. And we're used to using tools, implementing stuff, implementing frameworks and stuff like that. They recommend, those who have done some of the way towards Paradise, that you continuously invest in involving your infrastructure. Some of the companies, they say, well, we have a lot of tools that we used 4 years ago that we don't use that 4 years ago, and then we don't use them anymore. Some of them we still use for a couple of systems for some historic reasons, but we evolve with some of the new tools and the new opportunities that are given, and they didn't see that as a problem. Why should you automate things? Why should you look into these automation tools? Well, it ensures that things are always done the same way. So what human beings are really, really bad at is boring, repetitive tasks. And a lot of the things that we have to do in software development, at least when we have programmed our solution, what we have to do after that is just boring, repetitive tasks. What tools are really good at are boring, repetitive tasks that require precision. A tool never gets tired. It never makes mistakes. Well, they do make mistakes, but if they do make mistakes, then they do the same mistake again and again, and we can debug it and find it. It serves as an audit trail, so even if you're in a regulated business, or maybe if you are in a regulated business, maybe you should automate things, because then there is an audit trail that will demonstrate to the auditor exactly how this executable was produced. And it makes doing a task more attractive. So I had a master's student who did his master's thesis in the company where they claimed to be agile, they claimed to be continuous delivery and stuff like that. And then they had 80 hours of manual testing. So then the graphical user interface testing was 80 hours of manual testing, and they didn't do that continuously. And I asked him to look into these test cases to see whether it was not possible to automate these. And as they tried to look out for things that are really functional tests. So if I want to have a train ticket from Bologna to Parma, 2 adults and a child, that's not a graphical user interface test. Well, that I can input from my smartphone, Parma, Bologna, 2 adults and a child, and we have these fields, that's graphical. But the rest of it is purely functional testing. And that it actually returns, when I put in the money, it returns the tickets. And he came back and said that in the conservative estimate, then slightly more than 50% of what they call graphical user interface tests were actually feature testing. And one of the people we interviewed said that in his company they had a credo that said, do it once, do it twice, automate. Because if we do it twice, then we'll probably do it more times. This is Stuart Feldman. He had a problem back in the mid-70s when he was compiling, linking, loading his programs and had to test them and stuff like that. It took far too long time to type all the commands that he had to do manually, and sometimes he would forget some of the commands, he would do them in the wrong order, or he would make typing errors. So he invented make. And the result was that it was much easier to get feedback. And he was asking for feedback much earlier, much more frequently. And the same happens when we do continuous delivery. When we have an automated pipeline, then it's very easy to push the button and then we'll get an answer to the question, am I done with this feature? If it passes, then I'm done. But if we have some crappy processes, then we'll just get crap a little bit faster by automating it. A syndrome that we heard about in many of these different companies was it works on my machine, and I've heard that a couple of times also today. So if it works on my machine, then it should also work in production and everywhere else. It should work on your machine, it should work on his machine, otherwise we have chaos. And as a configuration manager, if there's something that we hate, then it's chaos. So we would like to provide a production-like development environment to these developers, a production-like test environment, and production-like test data. That means that if it works on your computer, then it will most probably also work in production. The last part seems to be the most difficult, to get live data to actually test things on. We saw many different continuous delivery pipelines. The first was a company that actually didn't do continuous delivery, but they wanted to do continuous delivery, and actually they didn't want to do continuous delivery to customers. That's why I put it in quotations. So they're doing embedded software, and they don't have access to the hardware of their clients. So they can't do continuous deployment. And most of their customers were very happy by picking up a new release every 6 months. And then you might wonder, why the hell do they want to do continuous delivery when no one is interested in the delivery until the delivery that is done in 6 months' time? And said, we want to do it because we believe that internally it'll bring higher quality and more efficiency in the development. And they're probably right. Company divided up into development, then it was put into test, then it was put into system test and into staging, and it seemed like everywhere there is an arrow, it means that there is a button and someone has to push the button and then it's sort of promoted. These two companies, this is the Paradise company and this is a company that is also quite good at continuous delivery, have been doing it for some years. What they said in this company was that we can actually, if we want, we could put something like 80% of our changes directly into production. But there are some things that we would really like to have in staging for a couple of days to see how it works out. Because there are some things that you cannot test in 2 to 3 minutes. So I don't know whether you read about the Boeing Dreamliner. It was half a year or a year ago. They discovered that if the electricity was switched on for 252 days, then it would run into integer overflow and it would automatically power down. I mean, imagine that happening during flight. I mean, this is a thing that you cannot discover in a 2 to 3 minute automated test. So you need to have some of these staging things as well. In this company, they say, well, probably for them this is sort of staging. And from experience, they said, well, we don't have any problems. We have not experienced any serious problems that we couldn't get out of by putting things directly into production. To have a tool team, dedicated tool team or not, this company is a company with one team of 9 to 10 developers. And they don't have a tool team. The team itself is responsible for the continuous delivery pipeline. This company has like 70 to 80 developers, 10 teams of roughly 7-8 developers each team, and then they have a dedicated tool team of 4 to 5 people. they say it's got advantages and drawbacks. The advantage is that these tool people, they're more specialized, they know what they're doing, and they're only doing this thing. When you interview one of the developers, they will tell you, well, whenever we want our continuous delivery pipeline to be changed, we have to wait for the tool team to do it, even if in some cases we could actually do it ourselves, because we don't own that code, so we cannot do it. People commit bad quality, build in quality gates. So it's difficult to know when you're done. Build in the quality gates, use test-driven development, then the test cases will tell you when you're done. How to handle unfinished code while you're developing it. You can do private workspaces, you can do feature branches, you can use feature toggles. Two of the companies, they used feature toggles. They didn't think that it was a problem. Their developers were able to do it. They didn't use it a lot. Last year I heard a presentation from Microsoft that said that they had used feature toggles, but they had abandoned them because the problem was that once you make the feature public, then people forgot to sort of remove the feature toggle. And it meant that slowly the code grew more and more complex than it should, because all the features were switched on. So you might as well remove these. It's difficult to get small increments. If people work too long in parallel, it creates problems. We can try to mitigate it by continuous integration. We could use feature branches and feature toggles. But the company has told us that you really have to focus on breaking down the stories into tasks. Ideally, a task should be a one-day thing. You can start in the morning, and before going home, you can commit, and it's in production or staging or wherever. A task should not take more than a week. And you can work on it either alone or in small groups. The numbers that we saw from some of the companies that provided numbers for us was that the average of deploys per developer per day was from 1 deploy per developer per day, which means that you get very close to the ideal of 1 task 1 day, to 1 to 2 deploys per developer per week, which means that you're very close to the upper limit of having it for 1 week. Delivering small chunks, one by one, makes it easier to roll back. It makes it possible to fix quickly, because you can very clearly identify that I have published this little thing, now it doesn't work. I know that this thing that doesn't work, I can go in and fix it, and I roll forward. And you're still in the stride. You just published it, you just wrote the code, you still got your head in it. So you don't have to pick up code that you wrote 5 months ago or something like that. People work in parallel, so this is Wayne Babbage. In 1986, he wrote a small book about the software configuration management for team collaboration. He identified 3 problems: shared data, double maintenance, simultaneous update. And the problem about double maintenance is that when we are working in parallel, sooner or later we'll have to integrate. And the longer we work in parallel, the more painful this integration will be. And you can Google merge hell, and you'll get some very interesting stories. So if we have problems integrating every month, then the solution is that, well, we'll integrate every 3 months, because then we have the pain only every 3 months. He also wrote that an ounce of duration is worth a pound of analysis. And it means that if we have a problem, then if we know the difference between now that it worked, before that it worked and now that it doesn't work, then the problem is this part. But if this part is that we have just released 152 features, then one of these features doesn't work. But if we have released them one by one by doing continuous delivery, then we can pinpoint exactly where it is it goes wrong. And then we are very close to fixing the problem. You should try to avoid the stop and go pipelines. So code reviews are interruptive. I know that many people, they love doing code reviews. Well, not developers, they don't like doing code reviews. Private code ownership is interruptive, because if I need something to change, I have to ask another person. Long-running tests are interruptive, because it stops me, and handovers and sign-offs are interruptive, because I have to wait for someone to sign off the thing. What should we do? Well, one company, they left it optional for the developers to ask for a code review if they found it useful. And they were doing code reviews on 10 to 20% of their changes. And the reason for doing code review was that I made this change, I implemented this feature. Maybe I did it in a little complicated way. Could you please check whether you could understand and maintain and bug fix and extend this? And the rule that they had was that I should have a reply from you within 15 minutes on the request for a code review. Usually it would take you like a minute or two. I had changed 200 lines of code. Everything that you have to do is to run quickly through these 200 lines of code. If you see that, yeah, basically I understand what Lars has been doing, code review passed. If you say, no, this is complex and complicated, you would say, Lars, you need to do something about this. Otherwise, I wouldn't send things into code review. Why should I do that? People say that code review, my students, they believe still that code review finds bugs. Yeah, maybe for my students, because they're really, really bad at testing. But this company says, we don't find bugs by doing code reviews. We have our automated test cases, and they find the bugs. Another company, they were doing after-the-fact code reviews. So we are doing collective code ownership here. So I would like to know a little bit about what you have changed, how the code has developed. So I review your code to get acquainted with how the system develops. Not to criticize you, not to find bugs, but with regards to the private code ownership, other people, other teams owning code that I would like to change, then one company used an internal open source system where I could change some things in another team's code, and then I could send a pull request to them. And the company that was in Paradise would refactor test into 5 minutes when they were sort of hitting into 2 to 3 minutes when they were sort of hitting the pain. Processes, test and QA is done in a sloppy way. Have pros write better tests. Educate your developers to make them cross-functional. Use staging when you don't have time to wait. Use ops duty. Put the people on ops duty. So you put something into operations. Now for an hour you will have and watch, sit and watch. If something happens, you broke it, you fix it. It actually works. To a certain degree, the final testing is done by live users, so you have to carefully monitor production to see what happens. So if you're not able to monitor what happens in production, then you have a problem, because then you're sort of blind. Quality has to be sufficiently good. There's a Swedish word for that, lagom, which means that you have to balance progress and quality. So some of my students, they believe that you can actually produce bug-free software. They will never release anything if they have to stick to that. Getting the whole organization on board, move business closer to development, and I've phrased this very, very carefully, so it doesn't say move development closer to business. So business has to move closer to development. It means that they don't have to talk to development every 6 months. They have to continuously talk to development. And they should not be more than 30 meters apart, because if you're more than 30 meters apart, you might as well be on the moon. We have to educate our developers, because they're no longer just programmers. They will also be testers, QA, requirements engineers, architects, designers, and whatever. And if we cannot make the developers cross-functional, then we should try to build cross-functional teams. And one person we interviewed said that it requires something special, so you should really think about this when you hire people. And when I presented this a week ago for the participants in our research project, then a company with 200 older developers said, well, that's not useful advice, because we got 200 old developers that we have to turn around to a new mindset. So the mindset for the developers, you are the sole responsible. No more over the wall. You should also learn and experience that you can actually deal with an issue. So that you do a deploy, there is a problem, and in very short time you can recover from that deploy. In the Paradise company, they said that they had actually had some of that experience and it fit really nice afterwards. And do you feel comfortable by pushing the button, knowing that things go into production? If you don't have good test cases, maybe you don't feel that comfortable, and it's a problem if people become afraid of doing things. We have heard a couple of presentations today, or at least there was the possibility to listen to some presentations about monoliths. So what is really a problem about a monolith architecture is the dependencies, and that many dependencies are invisible and not documented. So there's a really high probability of failure or breakdown. We want to minimize the risks, so we want to get these dependencies under control and to be able to make an impact analysis. If I change something here, what impact does it have on the rest of the system? There are several ways that we can deal with these. Now, very quickly, a trip through Paradise. So you can very clearly see from the clothing that this is a picture from before Eve took a bite of the apple and Adam discovered that he was nude. Well, we don't want to work, we want to stay in paradise where everything is beautiful and nice. So how did this Paradise company end up there? Well, actually their journey started 3 years ago, and it started by a 2-week sprint becoming 3 weeks delayed. So instead of taking 2 weeks, it took 5 weeks. And the CTO of the company said, "Mo basta. Ne dobbiamo parlare. We have to talk about this." And then they sat down and they analyzed it, and they went sort of directly into continuous deployment in a very, very short period of time. They had bi-weekly retrospectives focusing on process and people, not the code. Now, after 3 years, they do the retrospectives every 4 weeks because they have too little to talk about every 2 weeks. In the beginning, the CTO had a very serious conversation with the developers to put a strong focus on quality. He decided to trust his developers and to make the team responsible. So they are doing continuous improvement. And remember, continuous means without interruption. So they continuously improve and learn. For the technical part, they do refactoring, so they refactor the code, they refactor the test, they continuously refactor the architecture and the tool pipelines also when they have to do it. The social parts, the processes and the people, and to a certain degree tools, they do retrospectives. And one developer in the company said, when something is painful, you have to do it more often. Either you learn or you die. And in a company, it's not an option to die, so you'll have to learn. Refactoring, they spend, in the opinion of the CTO, they spend 30 to 40% of their time refactoring. They refactor architecture and design. They know that even though they are very good, their developers from time to time leave bad smells in the code. So someone eventually has to refactor that technical debt. And they do something that, for lack of a better term, I call it task refactoring. If you read Ken Beck's book on extreme programming, he says there's a big cycle where you have an iteration, and then there's a small cycle where you have a task or a story. And when you have to implement a story, you first look at the story and say, oh, I need to do this. Then you look at the code, and then you say, well, if I change the code in this way, then the code base is better prepared for implementing this story. This is the initial refactoring. preparing the code for an easy implementation of the story. And then you implement the story in the simplest possible way that will work, which is sometimes a little dirty, and that's why at the end you have to clean up the code so it becomes nice and clean. Apparently in this company they sometimes skip the last step. Tests are refactored too. There seems to be a 5-minute pain threshold. They parallelize the test and they run only selected tests. And the tools and processes are refactored too. So you feel the pain, you own it, you fix it. Testing and QA. The management, very early on in the process, told QA to go away and find another job in another company. And he made the team responsible end to end for everything, also the QA. What the CTO experienced was that when there was a QA, now you're a QA, on this team, then I tended to sort of throw my code over the wall to the QA and said, I don't want that. That's not the reason for having a QA on the team. So, since I cannot tell all my developers to go away, I'll have to tell the QA to go away, and now my developers, they will have to do the QA. They have sort of a 3-velocity testing, 3-minute testing, which means stop or go. If it passes, it goes into production. When it goes into production, you put it into production, now you sit and watch on it for an hour to see what happens. The developers we interviewed told us that this was the most boring task that you could get, because nothing ever happened. Once or twice per week. And you have to remember that they were doing 10 deploys per day. That is 70 deploys per week. Once or twice per week, something would show up during your ops duty for 1 hour. And in most cases, you could fix it within a matter of minutes. Then you could fix the code, and having a continuous deployment pipeline, you could have it out in like 5 minutes. Then they had nightly tests where they would test all the test suite, and whatever they found during the nightly test, they would consider that as a normal box. So I mean, if it wasn't found by the 2 to 5 minute test, if it wasn't found by actual live users in a production environment with live data in 1 hour, it was just a normal bug. And it would be prioritized whether it was critical or not. They had a weekly round-robin ops duty by the team during office hours. So a team of 9 to 10 people, one had to do ops duty every day. So if something happened during office hours, then the person on ops duty would have to fix that. In the beginning, the CTO thought that this would be a very boring task that none of the developers wanted to do. So today you have to do ops duty, tomorrow he will do ops duty, the day after tomorrow you'll do ops duty. After some time, at one of the retrospectives, the developers asked, well, couldn't we change this system of the ops duty such that instead of doing it for 1 day, we do it for a whole week? And the CTO asked why. Well, you know, when I've got ops duty today and I see a thing that I should really look into and fix, I know that he's got ops duty tomorrow. So if I don't do it, he'll do it tomorrow. But if I've got ops duty for a week, then I'll have to do something about it. This is not about tools. It's not even about processes. It's about human psychology. So we have to think that into it as well. And well, it's a really boring task because nothing really happens, not very much happens. They don't do planning meetings. The product owner, the CEO, and the CTO, they have bi-weekly meetings. They do short-term planning, which is mostly coordinating the things that have to be done. And they don't seem to have a global strategy on long-term. One of the companies that we're doing the research project with is working in the financial sector, and they say, well, the last bullet, that won't work for our company. But it works in this company. They have a proven track record, so when the CTO tells the CEO, well, trust us, we work as good as we can, then there's a proven track record, and they believe him. Management has business goals, and the team knows sort of the application that they're developing, so they can create the tasks that can actually deliver the high-level business goals that management has. My favorite is that this Paradise company has abandoned Kanban, sort of. I really hate Kanban. I can see what it does to my students, because at a certain point on my students' Kanban board, before it comes to done, and released, there's a column that says code review. Guess what happens? Everything stops in code review. No one wants to do code review. Oh shit, we got a release in 2 hours. We better do some code review. And then it means that now his changes have been standing still waiting for code review, your changes have standing still, your changes, and now we have to integrate. Do you remember what that's called? That's called merge hell. We don't want to have merge hell. They have a Kanban board which have 3 columns. The next great thing to do, which is where the CEO, the CTO, and the product owner sort of put things that they would like the team to work on. They prioritize it. And then in progress, what are you working on? What are you working on? What are you working on? I'm working on this thing. Thing is related to that other task, and oh, you're doing that. So I can know that I can talk to you. And then we also got in production, so the latest things that we have put into production. What they are doing, moving away, seeing, well, I can't actually quote the CTO for this because he didn't really say these words, but talking to him, I'm sure that I can have him say these words. Sprints are the root of all evil. Because sprints are not continuous. It means that we deliver at the end of each sprint. I read an experience paper from an American company. In the beginning, they were doing 8-week sprints, which turned into 7 weeks of programming and 1 week of hardening the code. Then they moved to 4-week sprints, which just become 3 weeks of programming and 1 week of hardening. And then they sort of saw the light and said, we need to continuously, when something is done, it should be done, and it should, at least in theory, be able to be put into production. And this is one of the things that this company has done. Now, what did you learn today?
What is continuous?
I can see you're a little bit like my students. When I get to this point, at least when it's not the exam, it's a lecture, then the students become silent, very silent. If I want silence in the room, I just give them that question. So one thing that you could have learned is that continuous means without interruption. We don't interrupt for code reviews. We don't interrupt because we want long, very good tests. We don't interrupt for anything. We want to have a continuous flow in this. We could come into more details. So what is it that we should look out for when we are implementing continuous delivery? Well, we should automate as much as we possibly can. Why? For the sake of reproducibility and ease, and also to have audit trace. We should strive to have one-day tasks, because then we minimize the time that people are working in parallel without having the possibility to integrate. And as Wayne Babbitt said 30 years ago, the longer we wait before we integrate, the bigger our problems will be. We should remove all possible obstacles for a continuous flow. So if 2-week sprints are causing us to have interruptions in a continuous flow, then we should remove that. If code reviews are stopping us, which they actually were in one company because they had, well, you should do the code review within the day. Sometimes it would be done the next day, which means that I'm waiting to have my thing put into production. Or, as different companies said, well, actually, sometimes I need your stuff. And I know that he has to review your code before it sort of, your stuff becomes public. So what do? Being a very clever guy, could you please pass his code? And you'll say, yeah, sure. And you'll push the button without having read it, because I have prayed you to do that because I need it. So that's what happens. That's human nature. So continuously improve and learn. I think that if you want to take away just one lesson, besides that continuous means without interruption, the reason why this company is so good is because they're doing focused retrospectives. They have had a very high focus on doing retrospectives, trying to continuously, 2 weeks after 2 weeks, to find what's causing problems, what can we do about it, and then do it. People are difficult, tools are not. And then another thing that they did in the Paradise company was that they empowered and trusted the team. So in the not so Paradise company, the CTO told us that they are not measuring test coverage on the code. Management is not measuring test coverage on the code. And so you really don't know what the test coverage is, whether you have a good or bad test coverage. He said, I, as a manager, don't know it. But I know that some of my developers, they know it. Because they want to know and they want to figure out if there are parts of the code that is badly covered by tests. But for me as a manager, I don't care. What's important for our company is 1, uptime, 2, number of bugs. When I trust and empower my team, I don't care how you deliver that. That's your problem, that's your responsibility. I want to have uptime, I want to have few bugs. If you can do that, having a 30 to 40% test coverage, I'm happy. You find the measures to implement what's important for me. So it's a little bit divide et impera. So I tell you what I want to have, and then I trust and empower you to give me what I want. And that you know better than me, because I'm a manager, I know everything. A little bit about everything. But you know a whole lot about the things that you're doing. A whole lot more than I do. And finally, never accept an apple for someone you don't know. You'll be kicked out of paradise if you do that. Thanks a lot.